Let's talk about the printing press assignment. Awesome assignment. This assignment will give you a good understanding of like full system design. We're going to look at a real application, a printing press, and we're going to look at the different actuators that make things go on the printing press. We're also going to discuss the control aspect of all of those actuators, how we control it, and we will be looking into the logic. We're also going to be controlling all of this, not only with electronics or electrical or electro-pneumatic control, but we're also going to be doing pure pneumatic control. So kind of an integration of both types of control systems. And it's going to be your responsibility to be able to decide on what types of cylinders, what types of limit valves and or limit switches, what types of control, and the actual logic itself. So the assignment itself details your design responsibilities. It also details all the functional parameters and all the types of equipment that you're going to be using, and walks through kind of the process itself, the operation of the process itself. So let's actually just delve into this and take a look at what this is all about. So here we go. So welcome to parts 1 and part 2. What we're going to do is we're going to talk about just part 1. Like, I don't want to overwhelm you. There's a lot of stuff in here. Just take it easy. I'm going to walk you through all of it. It looks more complicated than it is. So step by step, let's take a look at it. We're only going to look at part 1. Part 1 is actually, it's not very much work for you, really. It's simple. It's just getting over that hump, doing that first thing. It's like that first step in that what you perceive as this long ladder. It's not that long. It's okay. We're just going to get up on that first step. What you're going to have to do for step 1 is do your preliminary design. The preliminary design does not have to be correct, but you've got to put as much effort into it as you can. You really got to think about which kind of components to select, and you've got to think about the control aspect, and you've got to you've got to write down those solutions and submit them. Rough hand drawings. You can do it on Automation Studio if you want. That's fine with me. You can do it all by hand. That's fine with me. Again, this is a preliminary design, and you won't have to submit a report for stage 1. All you have to do is to submit 2 files. As long as the files have your name and your student number on them and your solutions, I'm fine with that. Let's move forward. Okay, good. Here we go. So this is the description of the process, and what's going on is that we've got a printing press over here, and the printing press runs on 4 pneumatic actuators. 3 of them are linear and 1 is a motor. And what's happening is that all 3 of those, I want you to design the control system with electropneumatics. But the actuator that's a rotary actuator, I want you to put 2 push button valves into that. So when you design this, you're going to design a rotary actuator, you're going to select the correct DCV, and you're going to select the right push button valves, and you're just going to draw that and put that in with the rest of the pneumatic drawings. Actually, if you want, you could submit, yes, I would like you to submit everything as one file. So if you're taking a couple different pictures, put them all into one PDF, and you know how to do that because you've been doing that with your homework already, especially in 110. So there you go. If you've got a bunch of different pneumatic like drawings that you're going to do, and or maybe a ladder logic that goes over 2 pages, that's fine. Just put them all in one PDF and submit that. So you are going to have to design all of that. Let's just move forward with this. The function of the bidirectional motor is to stir the paint. Okay, so at the beginning of the shift or any time during the shift, the operator is going to go over and he's going to press one pneumatic valve, which is a button, and that's going to rotate the pneumatic actuator, the rotary actuator, the motor, and it's going to stir the ink one way, and then it's going to stir the ink the other way by pressing the other button, back and forth and back and forth. So that's what's going to happen. Then the operator is going to go up and he's going to press a start button, which is going to be an electrical button, and the whole process will start. And there's timing and stuff in it as well. So it's a great kind of challenge to be able to think of how do I design the ladder logic for this? It's not that difficult. It's just kind of a lot of steps. That's fine. It's not like really complicated deep logic where you say, if this wasn't and that wasn't, and or the dog. Yeah, no, it's okay. It's just this happens, then this happens, then this happens. Okay, let's continue. Okay, so essentially what's going on, your report will be given to the manufacturer. So think of it this way. You are writing this final report, which is going to be stage 2. You're writing this final report to be able to give to the manufacturer to say, okay, give this to your technicians and they can build it. Go ahead. So you can talk shop talk. You can talk technician talk. If you're going to do calculations, you don't have to you don't have to show you don't have to redo the formulation and rearrange the formulation and then have the formula. Just go. If you want to rearrange the formula and just use it, just go. That'll be part of step 2. Let's not even talk about that. Step 1 is just about making that preliminary design. Okay, cool. So as far as all of the components go, these are the specifications for the components. So it's you are the designer. You have to choose what kind of linear actuators to put in there. Do they need cushioning? Maybe, maybe not. Do they have springs in them? Are they spring return, or what are they? You have to choose what kind of actuator you need. You know what? I'm going to jump into a PowerPoint for a second. So you can lean on this PowerPoint to help you kind of choose and select the components that you want to put into your system. So this PowerPoint was the PowerPoint on industrial pneumatics, industrial design. So this industrial design, you can just go through these and you can look at, okay, what do I need to put in? Do I need to put filtration in? You certainly don't need an aftercooler, just, it's okay. So, think about the different things. What kind of actuator do you need? Do you need an actuator that's got cushioning? Do you need, what kind of, system design, or what kind of components do you need? So this is an operation where you've got there's a good example right there. There's a rotary actuator right there that's controlled with 2 push buttons, and so this is just good. And there are a couple regulators in here and stuff like that. So you can lean on this to decide what kind of components you need. So going back to here, we can see that you've got to choose these specifications. I mean, you've got to choose which kind of actuators, which kind of valves to use. Maybe you're going to have a spring return cylinder. Maybe you're going to have a cylinder with cushioning. Maybe you're going to have a DCV with a spring in it. Who knows? It's up to you. You have to think about all those things and make those decisions. So, so this is talking about it. There's one actuator like this. Let me describe what's actually going on. Let me talk about the process first. What's going on is that there's this tray, okay? And there's an actuator that moves the tray, okay? So the operator comes and he presses play. He presses play. So this is the stamping process starts. He's already stirred the ink, okay? Presses play, there's a tray that goes. So there's a pneumatic actuator that pushes the tray, and then there's a clamp. A clamp comes and goes click, and clamps onto it, just right? Puts it into an exact position. Maybe it just only moves it like only this much, but it just puts it into an exact position. Now it's perfectly aligned, so when the stamp comes down, it's going to hit in the exact right place. So here we go. We've got this situation. We go, there's one actuator that does this. And then a clamp comes and clamps it. And then a stamp actuator comes down, it stamps, holds for a certain amount of time, and then comes back up again. Now that stamp is a heavy stamp. It weighs like 200 pounds. It's heavy. You might want to think about maybe adding some safety in there in your pneumatic system or your pneumatic lines and stuff like that. Okay, good. So let's go on about the actuators. You're going to need to decide what actuator does this with the tray. You're going to need to decide what kind of DCV is going to control that. You're going to need to decide what kind of actuator is going to be the clamp. It probably only moves this much. That's it. It goes in and then it goes right back. It's pretty quick. In and out. You're going to have to decide what kind of actuator to use there. Obviously, it's a linear actuator. You're going to have to decide whether it has cushioning or not. Vice versa, this one and this one also. You got to think about maybe the speed. Does it want to go really fast? Obviously, this guy, the clamp, can go really quickly. But this one, you might want to slow it down a little bit. However that's done, I don't know, right? And then you got your stamp. Your stamp's coming down. It has to move. It has to move slowly. Okay, good. So there's an actuator that moves the stamp down and then pulls it back up again. Now there's a timer in there that holds it, but that's the control stuff. Stamp down, hold for a little bit, come back up. That's got to move slowly on the stamp. You can't just go. Now it's a really heavy thing. It's like 200 pounds. So you don't really have to try and slow it down to pick it up, because it's so heavy, it's probably going to move up a little bit slowly anyway. So there you go. Those are the different actuators you need to put into your system. Okay, good. So that's what's going on. Let's take a look at this of the process of operation. Oh, by the way, I just told you the process of operation. So the operator comes along, he stirs the paint, back and forth, back and forth. That's a pure pneumatic system. And then he goes on, he presses an electrical button, and then the whole thing starts. Okay, there you go. So you can read the description, and there's some timing in there, 2 seconds here and there. So it's not difficult. Just read that description to get the details of what I just did all up and down with my hands and stuff. You can actually see the words. Okay, good. So system parameters. Oh, the entire pneumatic system runs on 75 psi. That's pretty good. The stamping cylinder applies a minimum of 140 pounds of force. Okay, so that's the cylinder itself. It's not how much force the stamp applies. The stamp is 200 pounds. It's heavy, right? It's this big honking, right? So, but the cylinder is actually applying 140 pounds of force. So that's 340 pounds of force onto the stamp. So that's a lot of weight. Again, you don't have to calculate the 200. I'm just saying it's important to think about the fact that the stamp is really heavy because it could be a runaway load. Huh. Maybe there's something about a runaway load that you can manage somehow with safety? I wonder about that. Okay, let's continue. So the stamping cylinder itself has to apply that. So the actual size and dimension of the cylinder has to be established because you know the pressure. The pressure is 75 psi. So if you wanted to apply 140 psi, maybe there's some calculations you can do. But you don't have to do that for your preliminary design. For step 1, all I need you to do is draw the pneumatic circuit with all the components and safety components as well. And to draw the ladder logic. That's it. Hand that in. No fancy report or anything. There'll be two places to submit those 2 files on Blackboard under the assignment. Just submit them. Okay, so let's continue. Control parameters. Okay, when the operator pushes both push buttons, electrical. So what's going on is that this is when we get into, actually you can put this into your control. If you can't fit this in quite yet, it's okay. It doesn't have to be part of the preliminary design, but it's a bit of a safety thing. I'd like to do something called 2 hands, no tie down. What does that mean? It's actually pretty cool. What's going on is that 2 hands, no tie down is a system where it's a safety system where the operator has to put his hands on both the buttons within a certain amount of time. You know, when they first started doing safety systems, they just put 2 buttons and back here so that the operator had to sit back and put his hands on both buttons so that he couldn't be at the machine when it was going ahead and doing its thing. So what we're going to do is we're going to do the same thing. The operator has to go and push both buttons down. Once both buttons are down, the press is going to do its thing. If he lifts his hand off either button, that is going to turn the whole system. It's going to freeze the system wherever it is. It will freeze it wherever it is. Now, that actually creates some difficulty because you can't just turn everything off. Yeah. Well, you'll figure that out once you actually decide which components you use. But it could be a problem. But let's just move forward. The emergency system where you have to get so there's an emergency stop where if the operator lifts either one or the other button, it's got to shut down. I want you to do that. The very last thing you add to your ladder logic will be that logic. Just start with the basic design first and then add the safety stuff in later. So moving forward, the operator is going to press a start button. It'll be 2 buttons. For your original design, you can just use 1 button, 1 start button. And then that's going to happen. And let me go back here. The operator, both hands, right? So yeah, both hands during the process. And the safety. So everything will stop. So if he lifts one hand or the other, the stamping cylinder will not continue its current stroke. Well, that's interesting. So if it's on its way down, it will stop in the middle. How do you do that? How do you make an actuator stop in the middle of its stroke? Huh. There must be a way. Okay, good. So the tray cylinder will stop and not continue into its current stroke. So this guy, right, if he's in the middle, he'll stop. Okay, that's cool. The clamping cylinder will retract. Actually, you know what? I'm going to change that. I want the clamping cylinder to stay extended. if it's extended. If it's extended, I want the clamping cylinder to stay clamped. Okay, that's interesting. I have to change that. Pardon me. Okay, here we go. So the safety occurs and then the safety system. So, you know what, read that and deal with that a little bit later. Let's move on. Okay, and then there's a reset. So now what's going on is that these are your duties. I've told you everything. You know everything now to go ahead and design the system. You know everything. You know the functional parameters. You know the operation itself. You know the type of control. You know the control aspects. You know what it's supposed to do. You know that there's a timing cycle in there. It's no big deal. I mean, whatever. It's not difficult. You don't have to write a whole report. Just do the two aspects of design. One is all the pneumatic components and then the control components. I would like you to also add air conditioning in there as well, or air preparation. I want you to think about it. So you can decide whether or not the factory or wherever this is, the print shop or wherever it is, if that has a lot of humidity in it or not. You may think about that in your filter design and your filter choice, filter strainer, or maybe you might want a water separator. It's your design. It's fine. I want you to also draw the compressor as well, and there are examples of the symbol of a compressor in that industrial industrial design PowerPoint that's posted on Blackboard. So you can understand how that works, and you have to put a regulator in it. You should label the regulator 75 psi. If you want, you can use kind of maybe a system where you can put like a pressure release valve that's set to maybe 80 or 90 psi just in case there's a system failure. And if you want, you can also add in some other things. Certainly you have to think about adding safety in. Yeah, that load runaway thing, you got to make sure that that heavy press doesn't fall down if something fails, like if the DCV fails. You have to think about that, add that in. So you may want to add some ancillary equipment as well, something we will deal with in the PowerPoint Industrial Design 2. We'll talk about ancillary equipment and stuff that you can add that maybe allows the systems to still work even if the compressor dies. But for now, your first main design is just going to be all the pneumatic components that you can think that are necessary. You have to choose them. You don't have to do the math to calculate the sizing. Not right now. You can go ahead and do that, but I don't want to see that in the submission. Just do the design of the pneumatic and then work on the electro-pneumatic control, or more specifically, the ladder logic. I would like you to design the ladder logic. Just start from a basic level and then work from there. Use a pencil. If you've got a whiteboard, use the whiteboard. And you've seen me on the whiteboard. I'm erasing stuff all the time. Yeah, you got to be able to erase your work because you'll never get it the first time. I don't get it the first time, and I've been doing this for 30 years. All right, okay, so there you go. So stage 1, it's due Sunday midnight of week 11. Okay, no problem. And then what you have to do is you have to do everything that I told you. But all of your design, just you have to hand in 2 files. That's it. 2 PDFs. If you stick them all on one piece of paper, 2 JPEGs or 2 image files, I don't care. It's fine. But you have to make sure that you get all of the symbols correct. Your ladder logic doesn't have to work. Doesn't have to be perfect. Your whole pneumatic system doesn't have to be perfectly correct either. You are getting marks for doing the design. It doesn't have to be the correct design, but it's got to be a lot of good work, and you have to use all the symbols. It's got to be hard work. You have to put some love into this. If you do that, you can't go wrong. Now, you need to use all the symbols, and let's just take a look at the rubrics. Okay, so here's the pneumatic rubric. Oh, look at that, 5 marks. You get the 5 marks that you draw all of the symbols, that you actually put all of the symbols in there, and that you've used the correct symbols. You get 3 marks for the correct symbols. You have to draw your symbols correctly. It doesn't have to be pretty. Don't do it with a ruler. Don't do it with whatever. It's a preliminary design. It's okay. You're probably going to end up erasing it and changing it. So I suggest you do your pneumatics design in pencil as well, because you're going to be erasing it and changing it. Okay, good. So it's a work in progress. So here's the thing about some help. I'm not even going to talk about, any of this. Just read this. This is my advice for how to do the work, how to actually do your preliminary design. And then that's your pneumatic rubric. And then the electropneumatic rubric, it's not in here. I apologize. I'm going to stick it in here, but it's pretty much the same. Okay, you're going to get 2 points for actually putting components in and putting some love into it and actually making something, attempting to make something work. You'll get another 3 points for drawing all of the correct symbols. That's it. There you go. You're good. We're done talking about stage 1, and then you can just submit it on Blackboard. Then we're going to talk about your designs in lecture so that you're able to then finish this report and do stage 2, which we'll talk about next week. We're done. Okay, bye.